Hi everyone, my name is Abby. Today we're going to be going through an exam walkthrough. So we're going to do the EECS 23 Fall 2023 Exam 1. If you want to find this and follow along, you can find it in the public Google Drive. If you go to the exams folder, there should be a folder with past exams, so you can find it there, download it, print it, whatever works for you. And then through that, you can follow along whatever you want to do with this. So before we start, just a little bit, I guess, about the format of this exam. So there's usually around 20 multiple choice questions, and then I would say anywhere from 2 to 4 free response questions. Usually the first exam has more free response questions. So the exam that we're going to be doing today has 4. But I think for exam 2, usually it's like 2 to 3 instead. And then just like some logistical stuff, make sure on your actual exam, like make sure you put your unique name on every page, make sure you sign your name, have the right like UMID, everything like that before you start the exam. Make sure that you're going there prepared with your M card so you don't get like thrown off guard later by needing it. But with that, I'm going to share my screen on my iPad. Okay, cool. So now what we're going to do is we'll go through and I'm going to write down the answers to all of them and just kind of like walk through why everything is what it is. Okay, so starting off, the first question is asking which statement is correct. So I can just kind of walk through. The first one is programs are written in pseudocode, and we know that this is not true because we're writing our programs in actual code. So we can kind of cross that out. We know that's not going to be true. And then an algorithm is a list of steps to solve a problem. Now, I know this is true because this is the definition that we give in this class, but you can kind of think of algorithms as like step-by-step instructions in terms of like whatever the algorithm is supposed to be accomplishing. So I'll just go through the other two and explain why those are not the right answer, but we know that this answer is going to be B. So C, the compiler can easily interpret ambiguous statements. This is not true. We know that the computer needs it to be very, very specific. That's actually why we have like coding languages and we don't just like write down our algorithm like in pseudocode. That's why we have to specifically write down everything in that special syntax that we use for C++. So we know that C is not the right answer. And then a program and an algorithm are essentially the same thing. We kind of just explained it, but the difference is really that like an algorithm is kind of like pseudocode. It's our step-by-step instructions. And then the program is where we're actually implementing that code there. So then we don't actually need to like write down the pseudocode because it's in that special syntax that we wrote. So there we go. Question 1 done. Question 2, which operation of the choices below gets executed last in the following code fragment? So we know that if we're using this like times equals, that means that we're going to be multiplying whatever's on the left by whatever is on the right. And then we see that we have 3 plus 1 on the right. So the first thing that we want to do is this part, which is 3 plus 1. So we're going to be multiplying 2 by 4, which is because y is 2 assigned here. So then we'll know that the actual last thing that's going to be executed in this is going to be answer C, 2 times 4. So fill that in. Okay, question number 3. Which expression evaluates to true if val is not between 20 and 40 inclusive? So the way I like to do questions like this is I like to walk through them, but if I'm not 100% sure on the answer, then sometimes plugging in specific numbers can be really helpful. So we'll start by walking through, but we might find with this question that we need to start like thinking of specific cases here. So the first expression, remember that each of these like subsections of this is going to evaluate to true or false. So we know that val is not between 20 and 40 inclusive. So this is checking not val is greater than or equal to 20 and val is less than or equal to 40. So this could be it, but I'm still not sure yet, but there's nothing that like explicitly throws me off. Answer B is val is greater than or equal to 20 and val is less than or equal to 40. So this is just checking that it's like actually between those two. So if it were like, say, 19, then this would evaluate to false because val is greater than or equal to 20 is going to evaluate to false. And remember, if we're using the and, then both sides need to be true for this to evaluate to true. So we know that B is not the correct answer here. And then C is saying not val is greater than or equal to 20 or val is less than or equal to 40. So again, I can not really tell what's going to work based on this yet. So I might want to plug in numbers. And then D, not val is greater than or equal to 20 and not val is less than or equal to 40. So I can kind of also look at this through the lens of like using numbers here. It's not looking at the entire thing together. It's like checking that value is not greater than or equal to 20 on one side and that val is not less than or equal to 40 on the other side, which since it's not looking at the entire thing together, then that's not going to work for us. So now we have these two statements that we've narrowed it down to. So let's just put in a number and check if it's going to work. So let's go with the same number that I was using before, 19. So if for the first one, we do val is greater than or equal to 20. If val is 19, that's going to be false. So that's one side. And then the other side, val is less than or equal to 40. And then if we look at putting that with 19 again, then 19 is less than or equal to 40, but this is going to evaluate to false still since we're using an ampersand. So then we are using the not operator outside of this whole thing, and not false is true. So that one is going to evaluate to true. And because of that, we can determine that that is going to be the correct answer here. Okay. What is the most appropriate data type to track the EECS 183 student population count? So I guess we can just kind of answer this based off of like, we know that there's not going to be like a half amount of students. So double is not going to be a good answer there because we're going to have like a whole number. And then char, string, and bool don't really make sense in this context because we're tracking a number here. So based on that, the only answer that really makes sense is going to be A, which is int. Okay. Given the following code fragment, what values are printed to the console? So let's just walk through this example. So n is initialized to 10, and then for I starting at 0 up until n equal n, then we're adding 3 every time that we go through this for loop. So I'm going to just draw out here on the side what n equals at the time. So n is starting at 10, and then I is starting at 0. And then every time that we do this, we want to print I modulo 4. So what we're going to do is look at this first. So 0 modulo 4 is going to be 0 because 0 divided by 4, there's no remainder. So it's going to print 0. And now we are adding 3 to I. And then we're doing 3 modulo 4, which is still going to be, oh, I did not mean to erase that, which is going to be 1 because 3 divided by 4 is going to give us like 1 remainder since there's 1 left over there. And now we're adding 3 again. Now I is 6. And then we are doing 6 modulo 4. And there's 2 remainder here. So we're going to print 2. And we're adding 3 again. So now I is 9. And then 9 modulo 4 is 3. So we're going to print 3. We're adding 3 again. And now I is 12. But when we check this condition here, 12 is not less than or equal to n, which is 10. So we're going to exit this loop. And by running through this, we were able to tell that all values between 0 and 3 inclusive is the correct answer. All right, let's move on. So in the following code fragment, which values of in A and in B result in yes being printed? So let's just walk through this with the examples that they give. So if in A is 7 and in B is 4, then whenever we go to this first statement, 7 is not less than 3. So this is going to evaluate to false. And then 7 is greater than 4. So this is going to evaluate to true. And remember, when we use the or Boolean operator, then only one of them needs to be true for us to be able to go into that loop body or the statement that the if is holding. So there, we're going to print out no. And so this one is not going to work for us because we want to be printing yes. And then let's do it with the next one. So in the next one, this one, in A is 6 and in B is 6 as well. So again, 6 is not less than 3. So this side is going to evaluate to false. But in A, which is 6, and in B, which is 6, technically 6 is not greater than 6. Otherwise, we would want to use like greater than or equal to. So this is also going to evaluate to false. So we'll move on to the next conditional. So else if in A, which is 6, is greater than 3, which is true, and in A is less than or equal to in B, and 6 is less than or equal to 6, so that is also going to evaluate to true. And since we're using the and Boolean operator, both sides need to be true for this to equate to true in general. So because both sides are true, then we are going to go into the body of this conditional branch there, and we are going to print yes. So by walking through it, we were able to figure out that B is the correct answer. And if we wanted to check it with the other inputs, which I always recommend to do, that would be a really great way to like double check your work. For the sake of time, I'm not going to do that, but I would definitely recommend that as like a tip to keep going. Okay, 7. Every group of if branching statements must end with an else branch. So this is going to be false. And the reason that this is going to be false is because we can have as many if statements as we want without an else branch. Like there's no requirement for an else. The only thing that is ever required with branching is that there must be only one if at like the bare minimum. So we could have like if something, and then we could have another if here. And then we could have like the else if and the else, and we can have like as many ifs as we want in a row. They're just all going to be checked individually. So remember that you only need like one if bare minimum, and then the else ifs and the else are optional. So that's why that one is false. Okay, moving on. How many times will the while loop execute? So let's walk through this. So I'm going to write down the values here. X is 1, M is 3. And then while X is less than or equal to 10, which X is currently 1, so we can go into this while loop, X is going to equal X times N, which is 1 times 3. So now we set X to 3. And then if X is greater than 5, 3 is not greater than 5. So we're not going to go into this if statement yet. But we've reached the end of our while loop, so we're going to go back up and check our condition. And 3, which is X, is still less than or equal to 10. So we'll go through this again and write down that we executed it 1 time so far. And then we're going to, again, do X is equal to X times M. So 3 times 3, which is 9. And then if 9 is greater than 5, which is true this time, we're going to go into this if body. So X equals X divided by M. So 9 divided by 3, which is 3. And X is going to be 3 again. And we'll notice here that we've already gotten to this point where X was 3 at the end of the loop. So I can kind of infer that there's going to be an infinite loop because of this. But if you wanted to like double check, you could just keep going through like we just did. And like you would notice that it went past like the options that you had. So there would be an infinite loop. But in general, this is like what we would want you to notice was that they kept like switching between 3 and 9 and then like kept going back and forth. So it ended up being infinite. So the correct answer here is D. Okay, now let's move on to question 9. In the following code fragment, what is the final value of Z? So X is 3, Y is 5, and Z is true. And we're checking if Y is greater than X, 5 is greater than 3. So we're going to go into that body there. And then we're checking if Z is greater than Y, and 2 is not greater than 5. So we're not going to go into this part here. And then else if Y equals 6. And we can kind of like, this is where they want to trip you up. Wait, honestly, like I started this problem probably for 5 minutes before I actually realized like why the answer is what the answer is. But what I want you to notice here is that Y is 5, but here we're using the single equals, which is the assignment operator, not the comparison operator. So this would be a different situation if this were actually Y equals 6. But since it's not, what's going to actually happen is Y is going to be assigned the value of 6. So now Y is 6. And then this is basically just going to be checking that value. So it's just going to be like else if 6. And if you remember, we talked about this a little bit in like lab. I don't know if they went through it in lecture, but with truth values, the only thing that is ever going to be false is 0, and then every other value is going to be true. So 6 is a non-zero value, so this is true. So then we're going to go into this loop body here, and then we're going to decrement Z by 1. So now Z is 1. And then since we've already gone into this, if once we reach the end, we are not going to go through this else code because we went through the first part. So we know that the final value of Z is going to be 1, which is B. And that is definitely something that I would just like keep an eye out for on exams. This is a pretty common like trick that they might try to trip you up with on something. So just make sure if you like walk through in this question specifically, there was no like option for like Z to be 2, but there could be on an exam. So just make sure that you're being super, super careful with stuff like that. Okay, question 10. Consider the following code fragment. What data type should be used to declare element? So in the following code fragment, we have this string name, which is Dennis M. Ritchie. And then we are initializing this variable element. And we see that we want to use element to access name, which is that string that we just created, at 7. And so name at 7 is going to be a character because you can think of strings as like arrays of characters. So in this sense, if we really wanted to, we could actually like go through the string and determine what character it was going to get, but it doesn't matter. It can hold anything in this string here. So we know that the data type that we're going to want to use to initialize and declare element is going to be C, which is char. Okay, let's move on to question 11. Consider the following code fragment. What prints if the user types big house and then enters after? So here we have our string stir being declared, and then we are using cin to read in stir, and then we are using cout to print stir at 4. So let's kind of walk through this example here. So stir, once we go to cin stir, remember that cin only reads up until the first instance of white space. So it's only actually going to read in big. And so when we try to access stir at 4, this is stir at 0, 1, and 2. So stir at 4 does not exist. And because of this, we can't actually print this since we're accessing something that isn't actually within that variable. And so there is going to be an error, which is answer E. Just remember, this is like something that you should know, like the difference between like CN and getLine. And so the big difference there is that CN stops at the first instance of white space, which would be like a space, and then getLine will go all the way up until the enter. So if we were to actually do this problem and put getLine with CN and stir instead of just using CN, then we would be able to read in that entire string and actually access stir at 4. But because we use CN, this is also kind of something that they're trying to like trip you up with to really make sure that you understand how CN works. Okay, question 12. If the modifies clause in the RME is modifies nothing, you can safely assume that the function will not print to cout. So yes, we can safely assume this. And you can just remember that modifies is always going to put like, if it's using CN or cout. And this is a really good pointer for like following for response questions as well, because you'll know like whenever you look at the RME, if it's going to like use CN and cout because it will say it there. So just remember that the modifies will always tell you if we're using one of those functions. So we can safely assume, since it says that it is modifying nothing, that we are not going to print to cout. Okay, moving on to question 13. Choose the answer that best describes when to use a for loop instead of a while loop. So if we kind of compare and contrast for loops and while loops, we'll remember that the big difference here was using like count controlled versus event controlled loops. So if we look at answer A, when the number of iterations needed is known, this kind of like stands out to me because I know that for loops were better for count controlled. So I'm going to put a little star next to this, but we'll go through the rest of them and come back. So when the loop counter is not updated, that's not really the purpose of a for loop, because remember we have those 3 sections and one of them is the update or the incrementation of that loop. So B is not when we would want to use a for loop instead of a while loop. And then C, when the number of iterations is not known, this is also not a situation where we would want to use a for loop instead of a while loop, because a for loop has that like I is less than X or N or whatever you want to call it. So because we have that like comparison check in our for loop, then we would probably want to use a while loop in this instance if we didn't know the number of iterations. And it's not none of the above because we've already kind of determined that A is a pretty good option here. So the answer is going to be A. Which is a valid function declaration for a function that accepts 2 integers and returns nothing? So again, if we like look through the like answers that we have here, let's first look and see that we want it to accept 2 integers. So the first one is fine because we have int A and int B, and that is pretty acceptable. So we want that. And then same for the second one and the third one. But then if we look at D and E, remember that whenever we're making a function declaration, then we actually need to put the data type of the parameters that we're putting there because we need to like specify it in C++. So we know that answers D and E are not going to be valid here because they don't specify what data type there. So we've already narrowed it down a little bit. So now let's look at this next part. We want it to return nothing. So the first answer, it's returning an integer. So we know that this kind of clues us in and tells us that that is not going to be the correct answer here. And then if we compare the next 2 options here, we'll see that B is return type void and C doesn't have a return type. So while C might seem like it's like the choice here because it doesn't have a return type, we actually want to go with option B because all of our functions need a return type specified, but void means that nothing is being returned in the function. So C does not work because we don't actually have a return type specified. So just remember, you always need to specify the return type, even if it's void, which just means that it doesn't return anything. Okay, moving on to question 15. Consider the following code fragment. What prints given the input 4, 5, 7, 3, enter? So again, let's just kind of walk through it. So here X is 3, and we have Y, which has not been assigned yet, and we have count, which starts at 0. So while C in Y And so cin, whenever we put that in our while loop, it's going to execute that action. So this part here is going to read in the first number from cin. So now y is going to be 4. So we've read in 4. And then we're also checking that x is less than y and 3 is less than 4. So we're going to go into that while loop body and increment count. So count is now 1. And now we're going to go back up and check the condition again for our while loop. So we're reading in y again, and that is 5, and 3 is less than 5. So we're going to execute the body again. And now count is 2. And then we're reading in y again when we go back into this while loop. And now y has read in 7. And 3 is less than 7 again. So we're going to increment the count in that loop body. So count is now 3. And then we're going to go back up and check that condition of our while loop again, since it's still going. And now we are going to read in 3, but 3 is not less than 3. So we are not going to go into this while loop body again, even though the CNY happened and evaluated to true. The x is less than y evaluated to false, and since we're using that ampersand, we need both of them to be true. So we're not going to increment count this time, and count is going to print to 3. So the answer is C. Okay. What values of J get printed to the console? So we just need to walk through this example. This is definitely somewhere we would just want to like go through the code ourselves. So let's put loop count here. Loop count is starting at 0. And then we are initializing our for loop starting I at 0. And then we are also initializing our inner for loop with J as I, which is 0. So here we're going to print J in our first iteration of this inner for loop. So J is going to print, which is 0, and it's going to print a new line, although none of these options in the answers actually like have a new line. So we're just assuming that we're like having the answer be like whatever actually printed the numbers instead of like the format. So the first number that we printed was 0, and then we are also incrementing the loop count here. So loop count has now been incremented to 1. And then we are now at the end of this inner for loop, and we're going to jump back up and check our conditions. So J, which is 0 currently, is less than 6 still. So we can go ahead and update J. And in this sense, we are updating it by adding 2. So now J is 2. And we're going to print J again. And now we're printing 2. And then we are incrementing our loop count again. So now loop count is 2. And then we're going to go back up and check the condition of this inner for loop. And 2 is less than 6. So we can go ahead and add 2 again. And then we're going to print J, which is 4, and increment our loop count, which is now 3. And then we're going to go and check our condition here. So J is 4. And then if we go up and increment it, then J is now 6. But 6 is not less than 6. So in this case, we're going to end this inner loop. And then here we're going to actually go to the next iteration of our outer loop. So now J doesn't exist since we finished that first one of the inner loop. And we're going to now iterate I by 2 since we've reached the end of this loop here by doing the entire thing of the inner loop. So now I is 2, and we're going to reinitialize J once we get back down to this inner for loop. So J equals I, so now J equals 2. And then here, we're going to, again, go through all of these iterations of this loop. So now we're printing 2 because that's what j is. And then we're going to increment j. So now j is 4. And then we're going to check 4 is less than 6. So we can go through this loop again. And then we're going to print 4. And now we are going to, oh, sorry, I just realized that I forgot to update loop count, but I think it's 5 now. And then we're going to update j again. J is now 6. And then 6 is not less than 6, so we're now done with this inner loop. So we're going to the next part. Remember, j is not in scope anymore, so it doesn't exist. And then we're going to increment I, which is now 4. And now we're checking this condition here. 4 is less than 6, so we're good to go through this for loop again. And now we're doing this inner for loop again. So j gets initialized to I, which is now 4. And so we're going to print j, which is 4, update our loop count, which is now 6. And then we are going to update j again. So j is now 6. But when we go to check our condition for this inner for loop, 6 is not less than 6. So we are going to be done with this inner for loop. And this is what we printed, which matches answer A. Lovely. And just to clarify, I feel like I explained this one a little bit confusing, but just make sure that for this question, you're always going to update your variable for the for loop before you do the comparison. So that's why it didn't end up being this one. Okay, moving on to question 17. Is it possible to duplicate the functionality of the code in problem 16 using while loops? So if we look at the code in problem 16, we'll see that it's the 2 for loops that we were just working with. And remember that anything that you can do with a for loop, you can do with a while loop and vice versa. So I'm not going to write down like what this would necessarily look like, but we can write like the outer loop and you would just want to do the same thing for the inner loop. So if we were going to convert this to a while loop, then we would need to initialize I outside of our while loop, and then we have the condition while I is less than 6. And then we would have like our inner for loop here, and or it would be the while loop if we were like converting it to while loops, but we can do the same thing here. And then we would have that update, which is I is plus or equal to. And so that would be like our outer while loop. So we know that we can convert it to while loops, so it is possible, which is answer C. Okay, let's move on. So we're given this following program, which is going to be used for the next 3 questions. I am not going to like walk through this, but I definitely recommend like making sure that you look at least like kind of skim over the code. And then once you see what the questions are asking, you'll go back and like look through them. But let's start with question 18. So which variables and or functions are in scope at line 6 excluding main? So let's go ahead and highlight. Line 6 is here. So anything on or above this line is going to be in scope at line 6. So that is add here, molt. And then remember we're excluding main, although that wasn't even like an option, but if they didn't say that, we would want to include it. And then both X and Y are in scope here. So the answer is going to be C, X, Y, add, and molt. Okay, moving on to 19. Which variable and or functions are in scope at line 14, excluding mains? So we're going to go and do the exact same thing here. Okay, so let's go ahead and highlight line 14, which is this function here. So we can go ahead again and look. So we know that both add and molt are still in scope here, because they were above this function. And then main is in scope, but the real difference here between when we were checking on line 6 and now how we're checking it on line 14 is because when we were checking it on line 6, we were within main. So anything that was above it within main was like good to be in scope. But right now, just the entire function of main is in scope. But that doesn't mean that we have access to these variables. It's just main. So none of this is technically in scope until we like are in the main function. And right now we're in add, so it's not in scope. But we do know that we have these two parameters here, A and B, and both of those are in scope. So we had add mult and A and B in scope, which is answer B. And then question 20, upon execution, what value is printed to the console? This question, we're going to want to walk through it ourselves. So let's erase all of this here. So execution is going to start in main. So here we have X as 2 and Y as 2 and total as 0. And then total is getting set to the result of mult passing in X and Y. So we're passing in 2 and 2. So we have C equals 2 and D equals 2. And then C gets set to C times D. So 2 times 2, and now C is 4. And then D gets set to D times C, which is 2 times 4. So now D is 8. And we are returning 8. And that was this line here. So total got set to the result of that, and now total is 8. And now we are setting total equal to total, which is 8. I'm just gonna write that over it. And then plus the result of add, passing in total and Y is still 2. So we're passing in 8 and 2, and we'll go through this the same way that we just did with the other one. So starting with A at 8 and B at 2. A gets set to A plus B, which is 8 plus 2, which is 10. And then B gets set to B plus A, which is 10 plus 2, which is 12. And we are returning B. So now the result of add total Y was 12. So now total gets set to 8 plus 12, which is 20. And then we are printing total, which is 20, and returning 0. If we go back here, it asked us what was printed to the console, which was 20. So E is the correct answer here. All right. Now I think, yes, we are moving on to our free response question here. So the first one, it wants us to write the definition for the function how high. And we have this RME here. And then they give us this box here, which on most exams, they will give you similar boxes like this, where it'll give you like the return type and the function, the entire like function declaration there. Sometimes they might have something that's like a box here if they wanted you to fill in one of the parameters or like the return type, something like that. But in general, this is what the exam format is going to look like for your free response questions. So let's just go back up. So we want to write the definition for the function how high, and it requires that vel is going to be greater than or equal to 0. It modifies nothing, so we can kind of infer that we are not using C in or C out in this function since it does not modify anything. And then the effects are that it calculates the maximum height of an object shot vertically with a velocity equal to vel using the equation h equals 0.5 times vel divided by g, where g is a constant equaling 10 and h is the maximum height. If h is greater than or equal to h check, return true, otherwise return false. And they give you an example there, which is useful. And then here it has our function declaration there. So we'll write it in the box on the next page. And I have like a sheet next to me that has this like entire problem there, but feel free to like pull it up somewhere else so that you can actually see the question while we're working on it, since we're going to write it in the box here. So we know first off that we have this constant G. And the way that they wrote this was a little bit ambiguous. So whenever we actually gave this exam, they would have accepted either like assuming that it was a constant declared outside of this function or declaring it yourself, which I'm just going to declare it ourselves because this is how the answer was in the answer key. So we're going to declare our constant. And remember, we need to put the const keyword in front of it. And then based on the RME, we saw that G was a constant 10.0. So that's going to be a double. And we're naming it G. But remember, if you're making a constant, they don't like specify what name. Constants need to be all uppercase. And we're setting this equal to 10.0. And then the next part is we want it to calculate the maximum height of an object shot vertically using that equation. And h is the maximum height. So double h is what we want, since we're going to be using this equation that has like 0.5 times velocity, and we want to be like very precise. So we're going to want to be using a double and not an integer here. And then we're going to use that formula that they gave us, which is 0.5 times vel, or that would be a star, times vel times vel. And then the last part is dividing it by G. And that is that part of this. And remember that vel was passed in as a parameter. And usually for problems like this, you're going to want to be using both things that they give you here, just to make sure that you're like doing the problem correctly. So the next part is if h is greater than or equal to h check, which is also passed in here, then we want to return true. Otherwise, we want to return false. So we'll go ahead and check that with an if statement. And we want if h is greater than or equal to h check, then we want to return true. And then otherwise, we want to return false. And then just make sure whenever you're doing free response questions, which also like, this is why it's so good to just go through these problems like before you start the exam and like make sure that you're simulating them like exactly how you would when you were doing the exam with like a pencil and paper, is because you want to make sure you're not having any errors. Like here, if we wrote this as greater than or equals to in this way, then we would get a point off for a syntax error because this is not how we would write it like in the actual code. So that would be a syntax error. Some other things that would be syntax errors would be like if you forgot a semicolon, and that's like a super common error that people get. So that's something that you would want to like make sure that you practice before the exam, or like write on your note card to remind yourself to do that. Just stuff like that. But those are usually pretty minor errors. But this is the entire answer for free response 1. So we can move to the next free response question. So assume population growth is exponential. Exponential growth is characterized by the doubling time, the time it takes for the population to double. Write the function pop count that accepts 2 integer arguments. The arguments are the doubling time, double time, and the total growth time, total time. The function calculates and returns the final population from the initial population. It should prompt the user to enter the initial population. Every doubling time the population doubles, assume total time will be divisible by double time with no remainder. So we have our RMA here, and it's telling us that double time is greater than 0, total time is greater than double time, and total time modulo double time equals 0. And then modifies is CN and Cout. So we know that we're going to use both of these. And the effects are prompting the user to enter the initial population. The population doubles every double time, calculate and return the final population. And then they give us an example, which would be useful if I was working through this. So the first thing that we want to do is we want to prompt the user to enter the initial population. So let's Cout something like enter your initial population. Sorry, I've been writing kind of big, filled up the entire thing. And then that message doesn't necessarily matter as long as it's something about like prompting them for their initial population. And then we're going to want to read in our initial population. So first we need to make a variable in order to do that. And populations can't be non-whole numbers, so we want it to be an int. And we want to, you could initialize it to 0. I'm not going to because it doesn't really matter since we're just going to read in and overwrite it. And then we're going to read in our population. So now if we go back to look at the effects, we've already done this first step of prompting the user to enter the initial population. So now we know that the population doubles every double time, and it wants us to calculate and return the final population. So based on this example, this is like a super helpful example for this problem. We'll see that if the total growth time is 6 days, doubling time is 2 days, and the initial population is 10, then the function is going to return 80. So we know that we have the total time that we want. So since we kind of have total time, which is like the entire cycle of iterations in a sense that we want to go, we're going to determine that we want to use some sort of count controlled loop here. So for count controlled, we want to use a for loop. So we want to go from I at 0, and we want to go all the way up until the total time, which was passed in as a parameter. And then let's go back and look at our RME here. It doubles every double time. So for our third part of this for loop, we're going to increment I by the double time, just because every time that we go through this for loop is going to be a time that we want to double the population. So that's why we're not like incrementing it by 1 or something. And then here, we're going to double our population. So population times equals 2. And then that is the rest of that part of our for loop. So now we've finished this double time calculation. And the last thing that we want to do is return the final population. And we can also kind of tell that they want us to do this because the return type is integer. So we are going to return population. And that's also another reason that population was an integer, because our return type was that integer. And so since population is what we're returning, then that is what we wanted to have the data type be. Okay, so now that is the entirety of free response 2. We're almost done with this exam. So moving on to free response 3, it's a little bit different than the other ones. And sometimes they do stuff like this on the exam, sometimes they don't, but it's good to just feel comfortable with testing just in case they do something like this, because usually there will be at least a question about it on the exam, even if that's like a multiple choice question. So free response 3 wants us to write 3 test cases that would expose 3 separate potential bugs in the function big find. Do not write the function definition. So we know that we want to write tests here. And the following is the description and the RME for the function big find. The function big find accepts 3 integer arguments. It determines the largest value, i.e. the number whose value is greater than the other 2, and returns the value. And it requires that none of A, B, or C is equal to the other. So remember that with testing, we never want to violate the requires. So if we had a test like this, big find 2, 1, 2, this would not be a valid test. So we don't want to do something like that because we want to make sure that our tests follow this clause here. So none of them can be equal to the other. It modifies nothing because that's just the modifies for this, but we can just kind of determine that we don't need to base it off of like if it's going to print something, or like if we want to have some sort of like input to read in, we don't need to worry about that for here. And then the effects of big find are it determines the largest value of the 3 parameters and returns the largest value. And it gives us this example that if the arguments are 1, 4, and 2, we're going to return 4 because that is the largest number. And then they give you a format here. So they want us to print the expected value of our test as well as the actual return value from the call to the function big find. So this is going to be super important part of when we're actually writing these tests here. We're writing them in the box on this page here. So really, there are a bunch of different ways that you could like end up writing these. There's probably like an infinite amount of possible tests, but the way that this question is kind of like asking you is that it wants you to write 3 test cases. So we know that these 3 test cases need to expose 3 separate potential bugs. And what that kind of points out to me is there's 3 parameters here. So we're probably going to want to test each of them to make sure that like there's no errors there, that like the largest number can be in any of these positions. And then if we test all 3 of those, then those would be like a good test suite. So remember that we want to print the expected value here. So we need to do cout expected. The largest value is. And then let's say that we could even do like the test that it gave here, 1, 4, and 2, but I wouldn't recommend doing that. I would recommend like writing your own just in case. That was like something that they had in the rubric, was that you had your own original test. But let's say that we want to test it with like the numbers 10, 4, and 1. So these are the numbers that we're going to use, 10, 4, and 1. So the largest of these is going to be 10. And then we want to print the actual, sorry, my cout statement is going to run over here, but I'm just going to put it on the next line. And the actual is going to be what is resulted when we call like the function. And then here, it doesn't tell us that we need to say like the largest value is. It's just like what the actual largest value is. So we can just say that we want to call this function so that it will print the result of that. So you could do this either by storing the result of big find in like a variable, or the way that I'm going to do it, which is just calling it directly in the cout statement. Something to like watch out for if you're going to call it in the cout statement is make sure that the function has a return type that can be printed to the console. So in this case, let's look at big find. We know that the return type is int, so we are allowed to do this. But if the return type was void, then we would not want to write a test case like this. We would want to make sure that our function call was outside of these cout statements. But since our return type is int, then we can just call big find. And then let's test the first parameter first. So we'll input 10, 4, and 1. And then I'm just going to put a new line here. And there we go. So this would be one good test case since we're testing this first parameter. And then for the rest of them, we basically want to do the same thing, but just check different parameter spaces. So now we're going to do the same thing, but here we want to test the second parameter. So I'm just going to swap these around and have it be 4 and 10. And then I'm going to do the exact same thing with our last test case and swap the biggest number into the last spot here. And it doesn't really matter which order you're doing it, but I'm going to test it for 110 because that would also be like an example of a good test case would be like if you are checking like that the first one is larger, but then like the second one is smaller than the parameter before that, that could be like a good test case as well. But bare bones, these would be 3 good test cases that you could write for this. But there's a lot of like interpretation here. It could be whatever like numbers that you want, as long as it is like intentional, like how we did it just now. All right. And now for response 4, we want to write the definition for the function big find from free response question 3. So if we go back and we look at the RME for big find, we know that it requires that none of A, B, or C is equal to the other, which is more helpful for free response 3. It modifies nothing, so we are not going to use CN or Cout. and it determines the largest value of the 3 parameters and returns the largest value. So we know that we're going to want to like return the largest value. So you can either do this by like storing the largest value in some sort of like integer here or not. Like you can just explicitly check them all. So we're going to start by having this largest here, and it's going to be 0, but that doesn't really matter since we're just going to set it as soon as we reach something that we want. So the first thing that we're going to want to check is, let's check parameter A. So if parameter A is bigger than parameter B and parameter A is greater than parameter C, then we know that parameter A is the largest. So we could either do largest equals A, or this could also be like return A if we weren't using this largest variable, but either way would be acceptable here. And then that finishes that part. Else, now let's check parameter B. So we want to check if parameter B is greater than A and parameter B is greater than C. Then the largest is B. Oh, this is supposed to be else if, sorry. And then else is our catch-all. So you could have this be like else if C is greater than B and C is greater than A, but since that's like the last thing that we're checking, remember that else is our catch-all, so we don't actually need any sort of parameter here since this is the last thing. And here we're going to have the largest equals C, because that is the only option after we've already determined that A and B are not the largest. And then if we do it like this, where we have a variable storing the largest, then we want to return that variable. And that is it for this question. Just something to make sure for this is that like you use the ampersand, but also that you avoid this super common mistake that we talked about in lab. So like if you were to do if A is greater than B is greater than C or something like that, you're not actually checking in this statement that A is greater than both of them. You're checking like the result of A is greater than B, which is going to be either 0 or 1 to C. So that's going to cause unintended behavior. So that's not what we want to do. But this is the good format, response, everything like that. And I think, yeah, that is the entirety of this. So how do I stop screen sharing? Okay. I want to stop screen sharing. Okay, cool. Well, we just walked through that entire exam. So I hope this is super, super helpful for you. We're also, if you're watching this in winter 24, we're hosting one of these in person as well. So feel free to come to that. We'll do a different exam than this one. So that should be pretty helpful as well if this felt like a good use of your time for studying. But other than that, good luck on the exam and yeah, have fun studying.